Okay. Is she with the government? I don't know. I know they're trying to record my stuff. All right. So, hello. Anybody have any questions about homework or just general stuff? You want to see more examples of something? Anything? No. Okay. I don't fully believe that. So I'm going to pretend like I'm a student. Hey, Mr. Waller, what? Can you do another cubes example? Oh, yeah. Let's do another cubes example. Good question there, Mr. Waller. Thanks, Mr. Waller. Jeff's been inside too long. All right. So, get out of the way. Let's try this out. So if I had, for example, x cubed plus 8. I think we already did this one. Let's do something more interesting. Let's do a cubed plus, what do you got, Jeff? 27w cubed. Sure, okay. So what are the steps involved? What's always the first step when you're trying to factor an expression? Anybody? What's the very first step? Maybe I should do this. Let's do this. Let me show you something. Let me see, where are you? There it is. Okay, let me see if I can show you this. Hold on, let me try to share this. This is up on Canvas. Can you guys see that funky paper with some red writing? Red writing. Yum. Oh, somebody answered my question. Oh my God, that's awesome. Sorry. So you're right, GCF. So at the very top of this really detailed full thing, there's this quick little quick reference guide. So you always want to, I call it the 0th step. First, look for GCF. No matter what the problem is, look for GCF. Then if there's 4 or more terms, you do grouping. If there's 3 terms, you do the trial and error, which is if the first one's a 1. Or you do the what's called surefire, master product, AC method, where you got to multiply the first and the last, right? If it's 2 terms, then you try squares or cubes. And you just got to take a minute and see, can I break everything in thirds or halves, right? So I've got an example of each of those types. And then on the other side is this. I don't know if you guys have even looked at this yet. I don't know what I'm trying to do. Go away. I'm thinking about doing a video doing each one of these. Would anybody enjoy that? No? Okay, I won't do it. Nobody wants me to do that. I won't do it. It sounded crazy. I agree. Nobody? No? You have enough videos in your life? Sure. Alex is like, dude, if you're going to do it, and I'll look at it if I want to. Okay. So, guys, I appreciate this. Melissa is spot on. You try GCF first, and we see that there's no GCF. There's nothing that comes out of these 2 terms, right? And there's 2 terms. So what the only things it could be are squares or cubes. And I'm trying to show you the most difficult thing about factoring. The first thing is learning the methods, but the most difficult thing for some people is, when do I do which method, right? In fact, that's general math thing is, when do I do this? When do I know to do this thing and not this other thing, right? That is a huge problem people have. Oh, interesting. Somebody said, I adore children. Try to do this real quick. Let me see what's happening. Hey, I'm gonna
it off like 10 minutes more?
Oh, I'm good. I'm actually doing this class right now.
Sure.
Thank you.
Sorry.
That's all right. All right. It's my friendly handyman for the place. He's going to shut the water off or something. I'm like, I don't need it for now. All right. So it's two terms. It's obviously which one, of course? Cubes or squares? So you guys like, it's too obvious, Jeff. I don't even want to say it.
Cube.
Cubes. Yeah. So I can break everything down into three parts. So a cubed is a. 27w cubed would be what?
9W.
No.
Oh, 3W.
Yeah. You're always thinking, what does it take 3 up to multiply to be the number, right? And then what do I draw here? Anybody know? What do I draw for myself here?
Grouping.
Not grouping, no. It's not 4 terms. So you can, maybe you just don't want to humor me. Little dude, big dude.
Big, okay.
Right? What goes in the little guy?
A plus 3W. And A squared plus
What goes at the end?
27W.
What goes in the end? Sorry? 9
9
W
squared.
squared. Let me stop for a minute. Please, you guys have got to get, there's 3 of everything. So if I put 1 of everything here, I've got to put 2 of everything there. So when I put them back together, there's 3. It's crazy. 2, 3. I couldn't do that fast enough. So what's the middle term sign going to be?
Plus 3W.
No. What's the middle guy's job? The middle guy's job is to cancel the stuff you don't want. So therefore, its sign must be negative. And then it's these two multiplied.
Okay, so it's gonna be the same.
One of these, the other two. One of these, the other two. The product in the middle. And that middle guy, what he does is he kills all the extra shit you don't want. Because I get my a cubed. I get my 27w cubed. This guy kills all the other stuff I don't want. And we've seen that happen. We've actually seen it happen. Okay. This is not impossible to understand stuff. You need to latch on to what makes sense. All of it makes sense, but not all of it immediately makes sense. I understand that. All right. Hopefully some of it immediately makes sense. Okay. So why don't you guys try this one? All right, Jeff, what do you got? Just a letter, Jeff. I know. What's it gonna be, buddy? Leave me alone. I'm so mean to myself. I don't know. Let's do sure. All right, try to factor this guy. How many people I got now? 13? We're at lucky 13. Yeah, I'll give you a little bit of a head start here. Let's see. Let's make him even bigger. Get over there. Brah. Little guy, big guy. So what goes in the little guy? What goes right here?
4m.
4m.
16 square. Oh, over there, y. Y
Sure.
plus.
No.
Minus is minus, yes.
Sign.
Sorry.
Plus, plus.
Yes, minus, the same.
The same sign. I love it. So now you're right. Let me catch up to
16.
you. That'll be 16m squared. What do we get?
16m square and y square. And here,
What sign will the middle one be?
positive.
Yes, because that's negative. It's got to cancel.
ym or my?
You normally put it in alphabetical,
Yes.
but you're missing something.
4,
Yes. So 4,
4 my.
1.
Yes, I got it.
Oh my. There you go. All right. That's probably people's most hated factoring method because it's more memorization than like working it out. The other ones you can sort of like, it's number puzzles, you can work it out. This is kind of like memorizing a little bit. 1 of each, 2 of each, product in the middle. I'm not going to make a song. Too bad. All right. Okay. All right. So let's take a step back. How would you do this one?
Excuse me?
Yes,
You put the last one plus y square.
definitely.
Put y, we have to put plus.
Because that's negative.
Yes.
What are these supposed to multiply to be? Negative y cubed. If I put a negative there, what's negative y times negative? It would be plus. Oh, shit. That's why. This is the same sign.
You need it to be.
This is the
Yeah,
opposite
negative.
sign. This is always positive.
I got it.
So,
I got it.
I like it. Everything we did makes sense. Everything we did, I have explained. But I don't want you to feel bad if you're still having trouble because this is very, very different than what we've ever done. So it will take a little while for it to sink in, but hopefully it does. Now, I'm not trying to trick you. Just pay attention. What do I do on this problem? Whoop. What do I do? What form is it in?
Where?
Yeah, so it's 2 terms. There's no GCF. It can only be cubes or squares. And it's definitely squares because everything can be cut in half. So this is the easier thing. Cubes, harder. 3 parts of everything, harder to juggle all that stuff. Here, just cut everything in half, right? So it'll be
A.
A and A minus plus
4, b and 4b.
Since everything is the same, except the signs are different, the middle terms will cancel, and that's what I definitely need to have happen. So this thing here, this whole term does what the different signs here do. That's why these are different signs, really, is so that this guy can do his job, which is to cancel all the stuff I don't want. Why does this one look worse? Because there's 3 of everything. There's more stuff to balance. Of course it's going to be a little bit harder, but you can kind of see the similarities. They're both trying to do the same thing. Kill all the terms I'm missing. Okay. So now I'm going to show you our first application of factoring. So factoring is just a basic skill. We haven't done anything with it yet. So you have to know how to factor, and then you're able to do the last section of this chapter and then the entire next chapter. I must stress this point, that if you don't understand factoring, you will not be able to do any of the next chapter. You guys got me? I'm gonna mute everybody real quick. I don't want to hear that, sorry. They're lovely, I'm sure, but no. Okay, so let me take this away. Tell me this. If I have a number times another number, right? I don't know what either number is, but I have one number times another. And I know that that equals 0. Do I know anything about what the numbers have to be? What has to be true?
One of them equal 0.
Yeah, so think about it. If you got a number 8, what do you multiply by to get 0? It's got to be 0, right? The only way that two numbers can multiply to be 0 is if one of them at least is, if they're both 0, great. If one of them is 0, great, right? The minute that neither of these is 0, there's no way in hell that it can multiply to be 0. Are you guys cool with that? Do you guys understand that? On one level, it's kind of like, well,
Yes.
yeah, Jeff. Huh?
Yes.
Okay. So then I can say right here, I can say either X is 0 or Y is 0. And that would be my answer. Because tell me this real quick. Why can't I be any more precise than that? If X is 0, what could Y be?
Any number.
Anything. So this is as specific as I could be for the answer. I like it. Now think about that. Now, all right. So right now that might sound like, what's that got to do with anything? Just appreciate that idea is simple and it's going to rule everything we do in this last section somehow. And it's a simple idea. In fact, if I had two numbers multiply to be 8, let's pick another number, not 0. What is it, only 0 that this works for? Why? If two numbers multiply to be 8, does either one of them have to be something? Does either one of them have to be 8? Think, come on, you can do it. Does either number have to be something? Give me two numbers that multiply to be 8.
2, 4.
Okay. Now somebody else, give me two other numbers that multiply to be 8. Anybody else? Is anybody else actually there? Is it just me and Youngsha and everybody else is a video like they do in those
8 and 1.
What's it again?
8 and 1.
8 and 1. Okay, thank you. I'll do another one. 16 and 1/2. Right? What's 16 times 1/2? Freaking 8. Right? What about 8/3 and 3? What's 8/3 times 3? 8. All right, so do either one of these have to be something? Nope. So this rule where I can answer the question only works if that's a 0. If it was any other number, then there's an infinite number of things that either of them can be. There's no known anything. It's got to be a 0 over here. All right. Hopefully on one level that's kind of silly. It's like if two numbers multiply to 0, of course one of them has to be 0. But if two numbers multiply to be something that's not 0, they could be anything. They could be anything. Okay. All right. Now watch this. Let me see who remembers this. Is this a number? Is that a number? You can do it. I kind of can go either way on this, but that's a number, isn't it? That is a number that I don't know yet because I don't know what X is. times, is this another number? Yes. So isn't that a number times a number, right? So for example, if x is 5, this is 3 times 9. Do you guys see that? Is that cool? If x is 5, this is 3 times 9 is 27. But I don't know if x is 5. Now, what if they give me this problem? They say solve. And this is equal to 0. What did we just learn we can do? Do I have two numbers that multiply to be 0? I really hope somebody out there thinks this is cool because
Yes, it's cool. X
oh,
minus 2 is a
yeah,
0.
either this number is 0 or this number is 0. Isn't that what we just said earlier? Remember when I had this up here? And then I wrote this down and now get out of there. Why? And I wrote this down and nobody said boo. Nobody disagreed with me. That only made sense. Two numbers multiplied to be 0. One of them has to be 0. Either the first one is 0 or the next one is 0. So what are the two answers for x? Do you see what I did now? I got this little easy equation. X is 2 or x is negative 4. That only works if that is a 0 over there. So of course you know that the problem's not going to start off like this. Right? Not all of them. Some of them might, but the problem's going to start off like this. What do you got, Jeff? Sure. Now, I really want you guys to understand, real quick. So write that down. We'll talk about it in a minute. But if that x squared wasn't there, let me write over here. If that x squared wasn't there and I had this equation, how would you solve this? This is just solving an equation, right? How would you solve this? What would you do? Somebody help me out. I forgot. I fell on my head this morning. Anybody? How would you solve this? Come on, we know how to do this. Nothing's tricky. This is back in chapter 2.
Plus 30.
Add 30.
Add 30.
And then?
Divided by -7.
Yes. Done, right? Why were we able to do that? Because are all of my x's together? Yes, they're all together. So I can get the numbers on one side, the x's on the other side. In this problem here, can I collect my x's together? Can I get my x terms to become one term? Can you? No, these are not like terms. I can't solve it this way if one of my variables has a higher or a different power than 1. I have to have a different way. And thank God we have this way. What do I have to do to this to make it look like this? Because then I know how to solve it. Of course, I have to factor this bad boy. So here's a use for factoring. Right? So I'm going to put x squared is x times x. What do I need? Two numbers that do what?
Add to be -7 and multiply to be -30.
Good. And they're the easier ones to think of. What's the answers? 30, it breaks up easily by dividing by 10, right? So you get 10 and 3. And that would make -7 if what? Which one's got to be negative?
10. -10.
Yeah. And then I can do like we did up here. Do you see that? Now I can say either this number is 0 or that number is 0. And then I can get two answers. Let's try to be a 3. My 3 is kind of Suck. Oh well. What's the highest power in this problem? How many answers did I get?
2.
If the highest power was 3, the most answers I can get would be 3. If the highest power was 8, I would expect to get 8 answers total, right? Some answers might not be real, but they're there. All right. So you guys try this one. Or man, 3. Open. What you got, buddy? Ba-ba-ba-bum. Sorry, had to step away for a minute. All right. So this does equal 0. I got to check to make sure it equals 0, or else I shouldn't do anything on this side yet, but I can go ahead. X squared is x times x. I need 2 numbers that add to 11.
9, 2.
Multiplied by 18, so that's 9 and 2. And they're both going to be, of course, positive. So either this number is 0 or this number. That's the only way I can have one number times another number equals 0. That's the only way to have it happen. That's why this has to be 0. Not quite, Abby? Or is that an answer? I'm sorry. Did I miss that from earlier? Sorry. Because what do you get when you solve these? Because some of you guys should get to the point where you don't even have to do this work. What plus 9 is 0? The opposite of 9, negative 9. See how that's the answer. What plus 2 is 0? Negative 2. So watch. What should happen then when I put a negative 2 back in here? What should happen if I put a negative 2 into this equation?
Make the equation equals 0.
Yeah, negative 2 squared is 4. Minus 22 plus 18. 4 minus 22 is negative 18 plus 18 is 0. Check. And of course, the same thing would happen if you plug a negative 9 in. The same thing. You can still check your answer just like always. Because the answer to an equation always means it makes the original equation work. It makes the original true. All right, so let's look at one that's got a little bit of an issue that we have to work out. All right, we need to become algebraic psychoanalysts, but that's all right, we can do it. I'm going to erase this. All right, nobody was yelling at me. So what is wrong with this guy? Ah, shit, I don't know where. I'm going to start over again with A. What you got, Jeff? So many things wrong with this poor guy.
Poor little dude.
And please, dear God, I always get somebody subtract x squared, subtract 6, divide by 4, and then circle it. That makes no sense. Your x's are on both sides. That's not solved. I can't combine these. That's why I need this other way to do this. What is fundamentally wrong with trying to apply the new way to this equation? What's wrong with trying to apply the new way to this equation? There's something that's supposed to be true before I start doing it.
Make the right side equal 0.
Yes, whatever's on this side, kill it. Why do I do, if that wasn't there, would I do that? If that first piece wasn't there? No, I'd subtract 6, divide by 4, I'd be done. Yay, that piece is there, shit. So I need this side equal to 0. Now I can do it because the only time that the thing we're trying to use works is if I have a product equal to 0. I need that side to be 0. How do you factor this thing? This one's nice. What two numbers multiply before, added before? Multiply before, added before.
2, 2.
2, 2. So either x plus 2 is 0 or x plus 2 is 0. Yeah, so I get x equals -2, and then I get it again. Math people are weird. We still count that as 2 answers. They just happen to both be the same. Right? If I get 6 people answer a question, I got 6 answers, even if they're all the same. So this is still 2 answers. They just happen to be the same thing. Okay. So let you try this one out. Riddle me this. Have you guys got all that? It's going away. All right. Here, you guys try this one out. What do you got, Jeff? Oh, this will be exciting. I give you the harder one to do on your own because I am a jerk. Sorry. This doesn't count for grades, so I don't care. Just try it. You know what has to be true. You should know how to make it happen. So just to make sure everybody's on the right track. I have a higher power on my x, so I need this side to be 0. How do I make this side become 0? What do I have to do?
-2.
Yeah, subtract 2 and
X.
what about x?
Negative.
No.
Add
I
x.
cancel those, right? I want to make it come out to be 0. We got to cancel them. So I got to subtract 2 and add x. So I get x squared minus 5x minus 36 equals 0. Okay, finish it up. Take us home. Country road. Mountain Mama. Take me home, take me home. to the place where I belong. Where the hell did this song come from? I'm sorry. I'll stop singing. This is the last section in chapter 7, by the way. Last section in chapter 7. Yes, I said that right. I think it's 7. Isn't it 7? Yeah. What do you guys get here? Anybody?
4 and -9.
Yeah, so -9 and 4. That'll make -36 and -5 when I multiply and add them. So then either this is 0 or that is 0. So either x is 9, add the 9, or subtract the 4, x is -4. Pop. All right, so let's take a look at the hardest example of this. Here we go. Here we go. You guys all got that? Okay. So now watch this. This is shitty. You ready? Shitty, shitty, bang, bang. Oh, let's see. Yeah. Try to make it work. Oh, that's so evil. I love it so much. I want you guys to have the right perspective on this problem. What is wrong with this problem? The very first thing we look for these kind of problems is what's supposed to happen.
The right side will be 0.
That's supposed to be 0. So the way I look at these problems where something's already broken up, somebody factored before they should have. They forgot to subtract 18. So what do I have to do? I have to undo the work they did. I have to unfactor this, multiply this thing out, x squared plus 3x minus 4x minus 12. And then I could do like they were supposed to in the first place. I can subtract that 18. That sucks so much because you're fighting against the idea that you're supposed to factor, but only when that's 0. Damn it, somebody factored. Ah, shit. Let me undo the factoring so I can subtract the damn 18, and then I can factor it again. Oh, well. Right? That kind of sucks, but it's the way to look at it. To keep it straight, what you got to do. Now, I can do this correctly. I can subtract 18, make it 0 like I'm supposed to. And then I can factor this. What would it be? Factors of 30 that add to be 1. They're different signs.
-6 and 5.
Yeah. So then either x is 6, become a 6, or x is -5. Kapow. Kapow. So just to let you know, I don't know if you guys, when I made this problem, I picked the number 6. I picked the number 6 because then I can do 6 minus 4 is 2. 6 plus 3 is 9. 2 times 9 is 18. The other answer I didn't know. I didn't, just happened to be another way to make it work. Just not the way that I thought of to get it set up. That's why I put an 18 there, because I knew it would work. All right. Okay, it's getting very hot in my apartment. I love it. I only have loud freaking AC, so. I want to show you one more thing. Don't forget, by the way, I don't think I said this at the beginning of class, but you all remember there's a quiz today, right?
Yes.
Yes. Yes.
Yes. Okay, I like it. And just to show you real quick, Where is it, Jeff? I don't know, man. That was your job. Ah, shit. You person. Jeff, give me a minute. I'm sorry. Well, I guess I'll do it this way. Yeah, okay. Okay, let me see. Oh, old man using technology. Just hang out. Here we go. Country road. Let me get to our class. Hold on. You guys can see my canvas, right? Math 90. Where was this? What was I going to show you? Oh, yeah. So I've already shown you this a couple times, but no, it was in announcements. That's right. In the announcements section, there's that updated timeline homework sheet, right? I updated it a second time. That's the last time I'm going to update it. Let me just hit here. This will be a preview. Load. There we go. So there's like today's quiz. Yay! And then the next quiz on the rest of chapter 7, and you can see everything else that's happening. Coolness? Coolness, Jeff. Okay. Take me home. Country road. All right, so here's the last thing I want to show you today. Come here. Do you remember your favorite? I mean, this is like, it was kind of weird how much you guys liked this. All right, well now these have a possibility of being very, very easy. One big thing I need you to realize is related to this, real quick. This is gonna seem kind of silly. Can I reduce 4 over 12? Can I reduce 4 over 12?
Yes, 1/3.
Why can I do that? I know it's a weird question, but why can I do that? Because 12
It's
has
not
a 4 in it, right? And when I say 4 in it, I mean multiplicatively. So this is obviously gonna be 4 over 4 times 3, so those cancel and you get 1/3. Can I reduce 4 13ths? Can I reduce 4 13ths?
No.
No, even though I could do 4 over 4 plus 9, right? Why does that not mean a damn thing? Can I cancel those 4s?
You have to put it in long division to divide it.
No. I'm showing you a better way. For some of these, there's a better way, but it's related to what I'm talking about right now. Can I cancel those 4s? That's my only question right now. Can I cancel those 4s? Why could I cancel those 4s? Because what operations are there? Division, multiplication. This is so fundamental, but I don't think teachers say this enough. The only times things can cancel is if there are opposite operations. What are the operations here? Division, addition. So how the hell would those cancel? There's no subtraction, so that 4 won't cancel. There's no division by 4, so that 4 won't cancel. You can't do that. So right here, don't kill an X. Don't do 30 divided by 10. No. Division cannot cancel parts of addition. So what can I do? The same thing I did over here. What did I do over here? I factored 12. Now, do we have to do that with numbers? No, because we can normally do that in our head without even realizing we're doing that. But here, shit, how do I factor the top? Because the bottom I can't do anything with. Multiply by 30, add to be 13.
10 and 3.
10 and 3. And then what happens? What operations do I have? Times and divided by. So what cancels?
X plus 10.
Yeah, this number cancels. So then I'm left with that number. So that's another use for factoring. Does it always work? No. If I made that 31, this whole thing goes to shit. I'd have to do long division, right? But actually, it leads to another shortcut, but we'll talk about it maybe another day. I just want to show you real quick. If X is 2, I know I've done this before, but just real quick. If x is 2, I'm done with this problem. Let me just make x 2 because I can make it whatever I want to. In fact, let me ask you this real quick. Let me see if anybody gets this. I just said I can make x anything I want to, but there's one value of x I cannot use here. This is a fraction, right? This is the
Oh,
big
negative
problem.
10.
Yeah, if I try to use negative 10, I'm saying that I'm dividing by 0. That's the only value of x I'm not allowed to use. So what is happening over there? Okay. So if x is 2, this is 4 plus 26 is 30 plus 30 is 60. Is that decent? Right, if you put a 2 in, you get 60. And if I put a 2 on the bottom, I get 2 plus 10 is 12. Anybody know what 60 divided by 12 is?
Yes, 5.
Now, if x is 2, what do I get over here? X plus 3 is 5, right? Do you guys, I don't know if you guys see what I'm talking about. So if x were 2, this fraction is actually 60 over 12, and it does reduce to 5. So why did I do all this work? Because now I did it for every possible value of x. If x is 8, whatever this is, it becomes 11 when you reduce it. So we just did an infinite number of reducing fractions. All right, I think that might be enough. I made it even a little further than I was planning on. All right. So right after this, man, that looked really, right after this, I'm gonna make the quiz active on Canvas. Maybe give me a couple minutes just to make sure I can get it going. So get in there and grab it and do it. It's due tonight, right? And just to remind you, if you're doing chapter 6 homework right now, stop. Do 7 homework. You need to be doing the more immediate homework. That is always your priority. The older homework you do when you can. You have to keep up so you're ready for quizzes and such, right? Okay. Any questions, guys? Anybody need to hang out afterwards for anything? You guys all good? That's the most you can take. I understand. All right. I'm not seeing anybody asking anything, so I'm going to shut things down. I'll go do that quiz right now. Get in there. Bye.
Thank you. Bye.
Bye-bye.
Yes.